So hi folks, welcome to SingDev Insights and welcome to my daily Leetcode challenging series. And in this today we will be covering another Leetcode problem, and let's go jump onto the problem. Okay, solving Leetcode 19 numbering problem. Remove nth node from the end of the list, and this is a daily Leetcode challenge from 3rd of March 2024. So without wasting any time, let's move on to the problem. And the one special thing about this problem is that this problem is kind of a most favorite kind of problem that is being usually asked in interviews that I have seen. So whenever in interviews this LinkedIn topic is touched, reversing a linked list or manipulating the removing some node is the kind of operation that is kind of expected from the candidate in interviews or the online test, so that it can be analyzed like how a candidate understands these node operations. So let's now move on to the problem. So as we see, this problem is a medium difficulty rated, and let's first of all read the problem. So given the head of the linked list, remove the nth node from the end of the list and return its head. Okay, we are given the head, we have to remove the nth node from the end and return its head. Okay, there are two examples given. Let's see the constraint, because this is the primary thing that you should always see in the question. Based on this, your approach might change. So the number of the nodes in the list is z. I don't know what it means. Okay, here they have defined the number of nodes as z, and as z is this length of the node can vary, like length of the linked list can vary between 1 to 30, and value can be between 0 or 100, that is inclusive. And the n number that they are saying is okay. So the last condition is just saying the node that we will be picking in the linked list from the end should be within the length of the list length. And so question clearly states, I'll just quickly see with the example. So we are, for example, given with the example, we are given a linked list 1 2 3 4 and 5. We are given this linked list. This is the input, and n is 2. Remove the nth node from the end of the list. Nth node. So this n value is from the last. So first value from the last is let me write here. The first value is this, and this seems to be the second value. Okay, if we want to remove this, the new representation should look something like this, I guess. Let me confirm here. Okay, yes, it should be like this. Now going with the second example, if there is a list with single element, then, and if we want to remove the node, first node that is occurring from the end, so itself this node will be removed and there will be empty list. So that means, yeah, there will be no element in the linked list. Okay, got it. Now seeing the third example, if they want to remove with the n equals to 1, means first element from the end, if it's removed, then it should be only 1. Okay, I think the examples are clear. So the problem says that we want to remove element from the end, but if we see the question in this, we are given just a head. We are always given a head and just a node number that we want to delete. Okay, so one thing that I see we can do here is we can actually take the, we know, okay, let's go with some example. We know that from end this 4 is having index 2, but what we don't know is what is its index. Like, yes, we want to know first, if, like whenever in the LinkedIn, so with linked list, we can only, with the information from the list node, we can only move to the next as per that is defined here. A node can have a value next, so we can go from left to right, but we don't have a mechanism, we don't have any information which tells us okay how to move from 5 to 4. Like we can't do like, okay, 5 previous is 3, and so no, 5 previous is 4, so let's remove 4. And like we have a direction in this way, but we don't have a direction in this way. So we have to get the information from it that tells us how do I remove this 4 from this direction. And for this I should be knowing the position of 4 when I go from left to right, but currently I know from right to left, that is 2. Okay, so if I know, let's think, if I know the length of linked list, if I know the whole length, and if I know that length from the end, that is 2, I can just do, let's take it as x, and from end it is n. So if I do x minus n, it will give me, I guess it should give me position of element we want to remove from front. Okay, and if I know the position of this element from front, I can traverse from this position till here, and what I need to do is, this element next shouldn't be 4, this element next should be 5. So with linked list, we can only, with the information from the list node, we can only move to the next as per that is defined here. A node can have a value next, so we can go from left to right, but we don't have a mechanism, we don't have any information which tells us okay how to move from 5 to 4. Like we can't do like okay, 5 previous is 3, and so no, 5 previous is 4, so let's remove 4. And like we don't have, we have a direction in this way, but we don't have a direction in this way. So we have to get the information from it that tells us how do I remove this 4 from this direction. And for this I should be knowing the position of 4 when I go from left to right, but currently I know from right to left, that is 2. Okay, so if I know, let's think, if I know the length of linked list, if I know the whole length, and if I know that length from the end, that is 2, I can just do, let's take it as x, and from end it is n. So if I do x minus n, it will give me, I guess it should give me position of element we want to remove from front. Okay, and if I know the position of this element from front, I can traverse from this position till here, and what I need to do is, this element next shouldn't be 4, this element next should be 5. So I want, I can say 3 is next. The way how we traverse in linked list is, the way we how we traverse in the linked list is, we have this information present next, and that's how we move to the next node. So 3 is next, right now is 4, but what I need to tell 3 is next is 4 is next. That's how we can remove this 4 from the list. Okay, I think the approach right now is clear to me. We will see on more approaches after going with this approach if we can do something better or there is any other way. But as I see, I am traversing this list once to get the length of linked list is, the way we how we traverse in the linked list is, we have this information present next, and that's how we move to the next node. So 3 is next, right now is 4, but what I need to tell 3 is next is 4 is next. That's how we can remove this 4 from the list. Okay, I think the approach right now is clear to me. We will see on more approaches after going with this approach if we can do something better or there is any other way. But as I see, I am traversing this list once to get the length of linked list, and second I am again traversing to actually removing. So I am doing 2 times the operation for traversing. So I see its time complexity should be, okay, O of 2 and something, it should be less, yeah, but it's, you can say it kind of O of n. And in space we are not storing anything, so it's it should be, I think complexity for that should be just constant. Okay, let's keep it here so we can revisit, or if we would be having any other approach. Approach 1, I've just written if we can find out some any other approach while going through it. Okay, so I'll be, for this question I'll be coding in Java, as like I use this language a lot in my job, and I kind of now like it, so it's just a personal choice. Okay, so I'll be, for this question I'll be coding in Java, as like I use this language a lot in my job, and I kind of now like it. So it's just a personal choice. Now I want to iterate over the list to actually find the length of the linked list. So whenever I'm iterating, as I told in my previous videos, we always assign we always assign this we always assign whatever is given in the input to some variable to make sure inputs aren't modified. This is not a good practice, so just remember that. So I'm starting from this, and I want to know the length of linked list, and naming variables is crucial. Is It helps in readability if someone reads your code. It is not just about solving a problem. These Leetcode, why these problems are asked in the interviews, as it just doesn't only check your DSS skills, but it also you have to also make sure when you're writing that the code has, the variables have a meaning, or they are actually just not IJK, as I have told in my previous videos. Because yeah, that is a kind of thing that is preferred in the company, that your code should be readable. Okay, when I'm talking I usually write sometimes wrong, so that may happen. I want to go till the end and take the count. Okay, so what I'm doing, I'm traversing until the end of the linked list comes, and length, this will give me the length. Now from front, I want to know front position. Front position is length of linked list minus position from the back, that is right now we have it. So as per approach 1, we have found the linked list, and now we want to remove it. For removing it, what we want to remove, let me explain this first with an example, because yeah, that can be tricky. These that are present the next, the way you move to the next node, these are the links. So if you want 4 to be removed, this link shouldn't be pointing to 4, but this link should be pointing to 5. So you want 3's next should be 5, and 4, we don't care about 4 next. Yeah, just we can ignore it. So for this front position, whatever will be coming, it will give me the position of 4. But when I'm in traversing, and if I have reached this node, then I don't have a mechanism to remove it. I want, when I am at 4, I should be keeping 3, so that I can write 3's next is equals to 4's next, something like that. So I need another variable to track what is the previous node from the for the current node, and that will help me to remove 4, and I can point this previous node to the next ones for the current one. Okay, if you don't understand, I'll just write the code, and then we can go through it. So what I need now is some previous node, and for example, the way how it starts, let me reuse the variable again, because right now the current node has been changed. Let me assign it again to head, and the previous of head, let's just say it's null, and we want to traverse it again. And when we are traversing for what? That current node doesn't reach the end, that is a priority. And also another thing, the front position isn't reached, so we will be decrementing it to make sure that when that position is reached, we break this loop. So we start with the first, right now, head. But what how this loop goes is, we want to move to the next, we want to go to the next, but before moving on to the next, we want to preserve the current one. And I think this previous node can hold it. That is, this way we will make sure we are moving ahead and keeping track of the current one also as the previous, and we will decrement it. Okay, I think till here we are good. We are moving and keeping the track of, as per this example, 4 and also 3. Now in this, I see there are two cases, but yeah, in question we have to always return head. So I'll, without thinking, I'll return head here. But one thing that I see is possible is based on if the previous node is null or not, the what we write may change. So for example, if previous node is equals to null, now this is the question to you: when this can happen, when previous node can be null. So we entered the loop, and when we entered the loop, there was suppose the front position comes out to be 0. Like, okay, the we want to actually remove, for example, we just want to remove the first element, or like we just want to go with this removal of the first or something like that. Then that is the only case I think the previous node can be null, and that would be a problem. What did I mean by that is, for example, I am given that I need to remove uh 1 2 3 4, I need to remove fifth node from the last, but the length is already fifth, right? So this would mean that I, from the first, I want to remove the first element, and that is kind of thing that if you want to remove that, then yeah, we need to actually change the head will be changed. So in this case, when the previous becomes when the previous node given is null, means we didn't iterate it, we want to make sure head is actually modified. But when it is not null, we want to make sure 3's next is 4's next. So that is previous node dot next is. These are the two cases I think that we should cover. This seems to be an edge case for sure. Let me go through this part. This part can be confusing. So when previous node can be null, like when we started, for example, someone says like this, remove fifth node from the end, that is n is 5. We want to remove 1. If 1 needs to be removed, then there is no like previous node to it, it's already null. And when it's null, I this null next I can't do, so I have to make sure of that edge case separately. And the other one is some intermediate element, in this case for example 4, then 3 is next, I want to make sure is 4's next. This will make change this link to a longer link, kind of like that. And that 4 is actually taken out because there is no information to how to go from 3 to 4, it's now 3 to 5. That's how we removed it. But okay, let's see if it works or not. I hope it should work. Okay, let's submit it. Okay, it did work. Okay, so as I mentioned, there is a second approach that I was having in mind, and because I have done this problem before many times when I was working for the interviews and the placement, so I'll be biased when I'll be solving that problem with the approach 2. So I expect you to come with the approach second, and I would be saying that is something more intuitive thing that you will be getting hands on. So try on it and mention in comments like were you able to get it. I'll definitely comment if the approach that you are mentioning is the one that I wanted to mention. And if anything that comes with you while solving this problem, you can definitely comment. I'll be replying back and giving the replies. And that's all for this video. And if you like the video, subscribe to my channel and turn on the notification bell so you'll be able to get my content that I'm working on for you in your career paths. Okay.